Good morning, dear students. How are you? I am Ramdas. I welcome you to my channel, Maths from Basics for You. So, I hope by now we should be well versed with all my 4 classes which I have conducted earlier. So, my first class was on formula for important formulae for differentiation. My next class was on, that is class number 2, was on trigonometric ratios. Class 3 was on trigonometric identities, and today I am going to start my class 5, that is from differentiation. So let's learn what is differentiation, because the stage is set to begin differentiation, and before that my funda is learn maths from basics, and I am there to teach you maths from basics. So let's put our best efforts and try to learn differentiation so that you are good in differentiation. So let's start. Now, to begin with, let me refresh you. I have told you the definition of differentiation. Differentiation is a process to find a derivative of a given function. So for instance, if you are given y equals f of x, so y is the given function y equals f of x. Here y equals a dependent variable. I have already told you about this. Anyway, I am going to refresh your memories. So x is an independent variable, and f is a function. F is a function. So y equals f of x. Y is an dependent variable and x is an independent variable, and the value of y depends upon the value of x. So now you are given, if for example you are given y equals, I write little big, y equals sin x. You are asked to differentiate this function. We will differentiate this with respect to x, that is by differentiating. I will write this in the beginning. I call this as equation 1. Differentiating equation 1 with respect to x. It looks like n, sorry. With respect to x, we get what? So what we have to do initially, we have to use y equals sin x. We have to differentiate with respect to x. It means to say that is dy by dx equals to, remember this, you have to write d by dx of sin x. I'll rub this so that you shouldn't get confused. So it means to say dy by dx equals to d by dx of sin x. Now you are about to differentiate. So what happens if we differentiate d by dx of sin x? We get cos x. So the answer is cos x. So if we differentiate dy by dx, if we differentiate sin x with respect to x, that's what you write, d by dx. It means to say differentiating this with respect to x. So it means to say that now it becomes cos x. Now let us think of another example. You are given y equals to tan x. You are asked to differentiate this with respect to x. So that is dy by dx equals to d by dx of tan x. So the answer is, I have told you this, secant square x. I have taught you this in the trigonometric ratios and trigonometric identities. So if you differentiate tan x with respect to x, we get secant square x. So now we have now come to know what is differentiation. Let us do more problems on the different types of problems depending upon the functions we are taking it. So now coming back to, let me rub this. If you want, you can copy this. Yes, I'll rub this. Okay, please copy, or you pause this and copy. Let me rub it. Now, we have different functions, like we have, I had told you earlier, we have constant functions, algebraic functions, trigonometric functions, log functions and exponential functions. So functions are of 5 types. So I'll write types of functions. Types of functions. First one is algebraic functions. Sorry, first one is, I take constant function. Constant. A constant function. Algebraic function. Algebraic function. Algebraic function is also known as polynomial function. Polynomial function. And next is trigonometric functions. Trigonometric functions. Next is log functions. This algebraic functions, make it plural. This is log functions. And lastly, exponential functions. So, functions, basically we have 5 types, that is constant functions, algebraic or polynomial functions, trigonometric functions, log functions and exponential functions. Now let us see what they are. So what happens if we differentiate a constant function? What happens to algebraic functions, trigonometric functions, logarithm functions, exponential? We'll study now. So to begin with, we'll see what happens to a constant function if we differentiate it. So I love this. differentiation of constant functions. So, differentiation of constant functions. Now, let us see, you are given a function y equals f of x, which is nothing but a constant c, that is y equals f of a constant. So, you are given a function where y equals f of x, where this is a constant. So, remember remember dear students, if you differentiate a constant, the answer is always 0. So, d by dx of constant is always 0. So, remember this and put it in your mind that if you differentiate a constant, you always get 0. So, let me see. That is y equals f of constant, Therefore, dy by dx equals d by dx of, I represent this as constant at c, so the answer is 0. So the answer is 0. So at least with this, what do you call this, 0, that is the icon, face icon, you think that it is 0. So don't forget, whenever you differentiate a constant, it is 0. So let us prove this. If you differentiate a constant, how do you get it 0? Let's prove. I'll write this. So here I'll write 0. To prove d by dx of constant equals to 0. We are going to prove this. So, let us consider a function y equals f of x, which is equals to c. Y equals f of x, which is equals to c. I call this as equation 1, where c equals a constant, where c is a constant. What I'll do is, I'll give a small increment of delta x to x and delta y to y. First, let delta x be an increment of x and delta y be the corresponding increment to y. So what I'm trying to do, I am trying to give a small increment of delta x to x and a corresponding increment of delta y to y. Let's see what happens. So equation 1 becomes what? Y plus delta y equals c plus delta x. So equation 1 becomes what? Y plus delta y on the left hand side. This is nothing but our left hand side and this is right hand side. So on the left hand side, equation 1 becomes y plus delta y and c plus delta x. I call this as equation 2. So I call this as equation 2. In the next step, what I'll do is I will subtract equation 1 from equation 2 or equation 2 minus equation 1. So subtract equation 1 from equation 2. What happens? We get what? On the left hand side, we get y plus delta y. This is our left hand side of equation 2 and this is minus 5 of the equation on the left hand side equals to what happens? So this becomes c minus c. So why I am taking the c plus delta x as c means whatever value we add to this equation c, it becomes c itself because it's a constant. So I write here the value, I'll write this the value of x, the value of x remains same for all values of c. All values of c. So whatever value you add, c plus c, let us take c equals to number 10. So c is a constant, number 10 is a constant. So if you add delta x as 0.1, so it becomes 10.1. It's a constant. So c will be neglecting c. I have taken c as a constant. Minus on the right hand side we have c. This minus c. What happens here? Plus y, minus y cancels, and this becomes 0. So delta y equals to 0. This is our equation 3. So this becomes 0. So therefore we are left with delta y becomes 0. Now what I will do is I will rub this and will continue. Shall I rub this? Yes. Now we are left with what? Equation 3. equation 3 is delta y equals to 0. So what I will do is, I will divide, this is nothing but our equation 3. What I will do is, I will divide this equation 3 throughout by delta x by dividing equation 3 throughout by delta x, we get what? Delta y by delta x equals to 0 by delta x. So I am dividing this equation throughout by delta x. I'll rub this. So that is this, that is delta y by delta x equals to 0. I'll rub this. Now what I'll do is, I apply limit where delta x tending to 0 on both sides. So that is by applying limits where delta x is tending to 0 on both sides of equation 4. I call this as equation 4. So what I will do is, I apply limits where delta x is tending to 0 on both sides of equation 4. That is, limit delta x tending to 0 dy by dx equals to limit delta x tending to 0 of 0. Therefore, this becomes dy by dx equals to 0. Hence I write properly. Hence, d by dx of constant is 0, which is proved. We have proved this. Please make a note of this. So, d by dx of, in a nutshell, we can say d by dx of a constant is 0. So, we have proved this. Now, let us think of, if we differentiate d by dx of a polynomial function or a algebraic function, what happens? Let's see.